Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we have guaranteed to make sure that you get 60 out of 60 in KCET 2025 exam within just 100 days. We are already almost over more than a month, and today we are going to complete the 7th chapter, that is alternating current PYQs. So we have already completed the chapter of alternating current in 2 parts. If you have not seen those 2 parts, the videos are available in our channel in the playlist for KCET 2025 physics section. Bookmark that playlist, and every day we are posting one video from chapters, from PYQs. Also on Sundays we are taking one test absolutely free. To attend that test, what you have to do, you have to join our WhatsApp group. Okay, the link is given in the description. Join our WhatsApp group, follow that, and every Sunday in the morning you will be getting question paper from chemistry, physics, and soon mathematics questions will also start coming. So don't worry if you are thinking that our channel has not yet started mathematics. Mathematics teacher will come soon, and we will be doing mathematics as well in our channel. So let's start with alternating current, and I hope you have already completed the chapter, and let's solve the problems one by one. This is a very important chapter. At least 4 questions come from this chapter. Some portions are out of syllabus from this chapter. I have tried to exclude as much as possible out of syllabus questions today. Okay, so that you don't get confused which part are part of the syllabus, which questions are not part of the syllabus. From going forward, I will try to exclude all the out of syllabus questions so that you don't get confused. If there are very less questions remain, that is fine. Later on, while doing practice, chapter wise practice, we will include more questions along with PYQs so that you can get maximum advantage from us. So let's start with the first question. In series LCR circuit, at resonance, the phase difference between voltage and current is. Very important question. We know that phase difference is phase difference is phi equals to tan inverse XL minus XC by R. Right now, in case of resonance, XL is equals to XC, right? So phase difference will be tan inverse 0 by R, that is tan inverse 0, that is 0. So phase difference between voltage and current is 0 in resonance. Okay, we have already learned that. If you can answer that without even doing this mathematics, fine. You know that phase current and voltage are in phase because the circuit is completely resistive. In resistive circuit, current and voltage are in phase. Phase difference is 0, so phase difference is 0. Now next question. An ideal transformer has a turn ratio of 10. Okay, whenever the primary is connected to 220 volt 50 hertz AC source, the power output is. Now for an ideal transformer, whatever power input, okay, that power input should be converted into power output. Power is a form of energy, so basically power is a converted form of energy. Power is energy per unit time, right? So energy has to be conserved, so power input equals to power output, right? So power output will be equals to power input. In practical transformer, there are heat losses and eddy current losses, and there are 2-3 types of losses in a transformer which are ignored in this case. So basically in an ideal transformer, whatever energy you are entering, same energy you are getting. So whatever power is getting entered into the system, the same power is received as output. Now the total impedance of the series LCR circuit varies with the angular frequency of AC source connected as shown in the figure. Now this is a out of syllabus question. This Q factor, I think this question I forgot to remove. So this question is out of syllabus. Q factor is basically resonance frequency divided by bandwidth. Okay, so now only I think I kept it because to understand that resonance is basically where the Z is minimum. Resonance is where this Z value is minimum, that is equals to R. Now this is the minimum value of Z, minimum resistance, and this distance is called bandwidth. So this is the resonance frequency, 500 radian per second. Bandwidth is maximum minus minimum. So it is simple, 500 divided by 600 minus 400. Okay, so 500 divided by 200, so it is 2.5. So Q factor is 2.5. It's a simple question, so that's why I think I kept it. Otherwise all other questions are removed. And alternating current is given by I equals to I1 sin omega t plus I2 cos omega t. The RMS current is given by. This is a very interesting question. What we will do one substitution. What substitution we will do? We will assume that I1 equals to A cos theta and I2 equals to A sin theta. I hope you are familiar with this kind of transformations, substitutions in mathematics, where you are substituting this kind of formulas so that your integration becomes easier. So that's what we are doing here. So if you substitute that, your current I becomes A cos theta sin omega t plus A sin theta cos omega t. Now can you tell me what is this formula is? If you take A common, you will get sin, let me write little bit extensively so that you don't get confused, because this type of problems you have never done in physics before. So cos omega t sin theta, right? This is a substitution. So sin A cos B plus cos A sin B. So what is the formula is? Yes, sin A plus B. This is the composite function, right? This is the composite current function. Now if you see, this formula is same as current equals to Im sin omega t plus phi. Phi is the phase difference, remember that. So here what is this Im? Im is A, right? So Im is A. So this is the amplitude or the maximum value of current. Okay, so they have asked you the RMS current. So first of all, let us find the A. So what is A? A is the maximum current, right? So what is the value of A? So we have substituted I1 is equal to A cos theta and I2 is equal to A sin theta. So if we square both sides, and add them, then what will happen? If we square both sides, I1 square plus I2 square equals to A square sin square theta plus cos square theta. I hope you are familiar with this kind of substitutions. So A square, so A is basically nothing but square root of I1 square plus I2 square, right? So let us put that value here. So amplitude maximum is nothing but I1 square plus I2 square whole root, right? So what is the RMS current? IRMS is maximum value divided by root 2. So it is nothing but square root of I1 square plus I2 square divided by 2 whole root, right? So let's take the option one by one. So correct option is option A. From the options given, it is clear that correct option is option A. If you still have any questions, don't forget to mention that in the comment. Okay, I will read and I will try to answer if you still have any doubts. Now let's move on to the next question. A series resonant AC circuit contains a capacitor of 10 to the power of minus 6 farad and an inductor of 10 to the power of minus 4 Henry. The frequency of electrical oscillations will be. So what is the frequency? So this is a resonant circuit. So in resonant circuits, we know that frequency is given by 1 by 2 pi square root of LC, right? This is the frequency, not angular frequency, normal frequency. So F is basically 1 by 2 pi What is L? L is given by 10 to the power of minus 4 Henry, and capacitance is given by 10 to the power of minus 6 Henry. So we can simply write this as 2 pi square root of 10 to the power of minus 10. So 10 to the power of minus 10 square root is 10 to the power square root minus 10 is 10 to the power of minus 5, right? So 10 to the power of minus 5. So you can simply solve this as 10 to the power of 5 by 2 pi, or it will be, if you take 110 out, I think I taught you this trick once before. So it will be 5 by pi times 10 to the power of 4. So 5 by pi 10 to the power of 4, or okay, they have directly given it as 10 to the power of 5 by 2 pi, so we don't need to do this method. Okay, so 10 to the power 5 by 2 pi is the correct answer. Now let's move on. In a series LCR circuit, R is 300 ohms, L is 0.9 Henry, capacitance is 0.2 microfarad, and omega is equal to 1000 radian per second. Then impedance of the circuit. Before finding the impedance, what we have to do? We have to find XL, which is equals to omega L. So omega is given 0.9 Henry. Omega is 1000. Omega is 1000. L is 0.9 Henry. So it will be 900 ohm. As I said, that unit of XL and XC is the same as that of the resistance, right? And XC will be 1 by omega C. So what is omega? Omega is again 1000. What is C? C is given by 2 microfarad. 2 microfarad means 2 times 10 to the power of minus 6, right? So it will become 1 by 2 times 10 to the power of minus 3, or XC will be 10 to the power of 3 divided by 2, that is 500 ohm. Okay, so 10 to the power 3 means 1000, 1000 divided by 2 is 500, right? Now, so what is the impedance? Impedance is Z equals to square root of R square plus XL minus XC whole square. So what is R square? R is 300 whole square plus 900 minus 500 whole square. So if you see, 100 square is common in each term. So even after this 300 square, if you find this difficult to solve, I am going to teach you one trick. So 300 and 400 both have 100 and there is a square also. So what we will do, we will take that 100 out of the square root. Okay, so square was there, so I have taken that out of the square root, so square was gone now. So only thing left is 3 square plus 4 square. Now I hope that this is very common, very familiar. What is the value of 3 square plus 4 square? Yes, 5. Okay, 500. So you need to remember these shortcuts. Okay, or you can do that. 3 square is 9, 4 square is 16, add them 25, 25 square root 5, everything is fine. If you remember, it will save some time. Even important 2 seconds is very, very crucial. If you are running out of time at the last moment, that 2 seconds might help you to answer one question. Now let me rewrite this figure so that you are not confused. Okay, so what will be the readings in the voltmeter and the ammeter? Okay, so XC is given 4 ohm, XL is given 4 ohm. Now tell me what type of circuit it is. If both XC equals to XL, that means what is the circuit? 45 ohm. Okay, now what is the circuit? XL equals to XC. XL equals to XC means it's a resonant circuit. Resonant circuit. Why? Because XL equals to XC, right? So if XL equals to XC, we can call this as resonant circuit. In resonant circuit, only effect of R is there, only effect of R is there. Now, so what we can do, that we can consider in this particular case, we can consider this is simply a conductor, there is nothing there, right? We can ignore capacitance, we can ignore the inductor, only they are simple conductor without any resistance. So voltage across any simple conductor without any resistance should be equals to 0. If we had applied the voltage across the resistor, okay, across the resistor, okay, if the voltage is, voltmeter is applied like this, then we would have got some value. But since this, you can consider this as a simple conductor without any resistance, resistance is connected somewhere here, so you can simply ignore this part, so voltage across them will be 0. But current will be not 0, because current is basically V equals to IR, so I is equal to V by R. Now everything is in RMS value, so don't worry. So 90 volt is given in RMS value, a resistance is simply 45, and the ammeter will only measure RMS value, so it will be 2 ampere. Okay, so current is 2 ampere, voltage is 0 volt. Right, so 0 volt, 2 ampere is the answer. Be careful, do not answer 90 volt, it will not be 90 volt. If you have applied the voltage across the resistor, then it would have been 90 volt. But since it is applied across the empty part where nothing is there, because in resonance capacitor and inductance, they cancel each other's effect, so there is nothing there, so you can simply consider that as a simple conductor without any voltage drop across them. Now, a series LCR circuit contains inductance of 5 millihenry, capacitance of 2 microfarad and resistance of 10 ohm. If a frequency AC source is varied, what is the frequency at which maximum power is dissipated? So I think I have solved this problem. The value of maximum power dissipated should be equals to the resonant frequency. So maximum power, max power at resonance. So now you can understand the resonance is the most important concept from this chapter. So at least one question every year is coming from resonance. So make sure you are well familiar with resonance. Okay, Q factor is not there, only resonance frequency is there. So either if it is given in terms of frequency, that is Hertz, then F is equal to 1 by 2 pi square root of LC. If it is given in terms of omega, then omega is equal to 1 by root over LC. Right? So you have to be careful. Resistance is not at all required in this case. So 2 pi L is 5 millihenry. 5 millihenry means 5 times 10 to the power of minus 3. Milli means minus 3, and capacitance is 2 microfarad. 2 times 10 to the power of minus 6. So let me simplify. 2 pi square root of 5 to the 10. 10 plus 1 minus 3 plus minus 6. So that is minus 9 plus 1. Minus 9 plus 1, that is minus 8. So square root of that will be 2 pi square root of minus 4. Minus 8 was there inside the square root, it came out to be a minus 4. Now it will be 10 to the power of 4 divided by 2 pi. Now if you check the options, 2 pi is not there anywhere in the denominator. So in our last problem we tried to do that, but in the last problem the option was given like that. So but in this problem we have to simplify it a little bit more. So 5 by 2 pi times 10 to the power of 3, okay, Hertz. I hope you have understood this step. So 10 to the power of 4, we have break it down to 10 times 10 to the power of 3. So we have simplified it. Right. Now let's move on to the next problem. A step-down transformer has 50 turns on the secondary and 1000 turns on the primary winding. If the transformer is connected to a 220 volt AC source, what is the output current of the transformer? So what is given? Given is the primary voltage. Primary voltage is 220 volt. Okay. Turns of the secondary, turns of the primary is 1000. turns of the secondary is 50. Right? Now we know that Vp by Vs equals to Np by Ns. So we can find Vs as Ns by Np times Vp. Okay, it's a step down transformer, so secondary voltage should be less than that of the primary. So what is Ns? Ns is 50, Np is 1000 and Vp is 220 volts. Okay, 0 0 cancels. 5 times one more 0 can be cancelled. 22 times 5 is 110 divided by 10, so 11 volts. So 11 volts is the voltage of the secondary. Now what else we know? We know that Vp Ip is equal to Vs Is. So there should be at least one of the currents should have been given to be able to solve this problem, but no current is provided. So from this information only you cannot solve the problem. Okay, at least one current should have been given, only given the voltage is there, so that means you can only find the secondary voltage, you cannot find the current because resistance is also not given, any other information is not given, so you cannot solve this problem. So this was a bonus question in the corresponding year. Now let's look into the next problem. In the given circuit, the resonant frequency is, now if you see, this is a LC circuit. Now LC circuit explicitly is not part of your syllabus, but resonance frequency for LC circuit and normal LCR circuit is same. So to give the emphasis that resonance is the most important concept from this chapter, I have kept this question. So we know that resonance frequency is nothing but f is equal to 1 by 2 pi square root of LC. So here 2 pi square root of L is 0.5 millihenry. 0.5 milli means 10 to the power of minus 3 and it is 20. And if you see, most of the combinations are this similar combinations. Okay, this is a similar combination. Every question, almost each and every question they are giving you such that 0.5 times 20 is 10. So they are giving you the same values also. So if you solve one problem, and even if you have not properly understood that, you can still answer that. Okay, so 0.5 times 20 is 10. So 10 is 1 minus 3 minus 6. So same thing, that is 1 by 2 pi times 10 to the power of 4 minus 4. So it will go up and it will become 10 to the power of 4 divided by 2 pi. Now here it becomes little bit complicated. So you can still solve it. How you can solve it? We know that this will become pi 5 by pi times 10 to the power of 3. So 5 by pi means 5 divided by 3.14, okay, times 10 to the power of 3. So it will come out around 1.5, okay, 1.5. So you can write this as 1592. Okay, you can check the order. Okay, from the order it is clear that it will be of the order of 10 to the power of 3. So 1 point something into 10 to the power of 3, that is the closest answer is 1592. That is also fine because all the others are given in the different order. So even if you are not able to find exact value, check the order. So these are the things, these are the basic things that you have to adapt to crack 2025 KCET. Okay, KCET, the options are given so intelligently that even if you are not able to use calculator, you can still able to answer the question. Okay, they are not very tight, they are not very just a 1 decimal or 2 decimal difference. No, They generally give the lot of things so that you can answer this question. Now this is another question. In the given circuit, the peak voltage across C, L and R are 30 volt, 110 volts and 60 volts respectively. The RMS value of the applied voltage. So what is the peak voltage of the output voltage? Applied voltage, it is basically VR square plus VL minus VC whole square. So VR is 60 whole square plus VL is 110 and VC is 30. Whole square plus 80 whole square. So you can take 10 out of the root. So it will be 6 square plus 8 square. 6 square. So what is the V? V is 10 times 36 plus 64. That is 100. 100 square root is 10. So this is the peak voltage. Now they have asked you to find the RMS value of the voltage. So RMS value is, this is the peak voltage. So Vmax divided by root 2. So it will be 100 divided by root 2, which will come out to be around 70. So correct answer is option 70.7. Right? Now let's move on to the next question. The frequency of an alternating current is 50 Hz. What is the minimum time taken by the current to reach its peak value from the RMS value? So V is equal to Vm sin omega t. So what is given? The frequency is given as 50 Hz. What is the minimum time? So frequency is basically omega is equal to 2 pi f, right? So 50 Hz is given, so just put the value. The value will be 100 pi, right? F is equal to 50. So omega is basically 100 pi. So what you have to do, you have to find the time for which this value will reach its RMS value. So what is the RMS value? RMS value is Vm by root 2. So that is equals to Vm sin 100 pi times t. So sine of 100 pi t equals to, this will cancel. So it will be 1 by root 2. So if you remove the sine, what you will get? 100 pi t equals to, this is sine 45 degree or sine pi by 4. Okay, because it is given in terms of pi, you have to write the values in terms of pi. So pi by 4. So that means t equals to pi cancels, 1 by 400 second. 1 by 400 second. That means 1 by 4, that is 0.25 times 10 to the power of minus 2 or 2.5 times 10 to the power of minus 3. So 1 by 4 means 0.25, right? 1 by 4 means 0.25 and there was 100 multiplied. So what I have done, I have taken that 100 that was in division, so I have written this as 10 to the power of minus 2 and 1 by 4 is 0.25. So these are the shortcut practices, calculation practices, mostly shortcut calculation practices is most important. So the correct answer is 0.25 times 10 to the power of minus 3 second. Now let's move on to question number 13. The reading of ammeter and voltmeter in the following circuits are respectively. So they have asked you to find the readings of ammeter and voltmeter. This is a similar question that we have solved, but in this case the voltmeter is applied across that of the resistance. If you remember this problem that we have solved, also here voltage is given by 50, I hope it is clear to you, and this is also 50. So this VL is equal to VC, that means this circuit is in resonant condition. So whatever current is flowing, it will only because of this resistor. So current I will be V by R. Now in this case I am writing everything in capital because this 220 volt is in RMS. Also voltmeter and ammeter will only measure RMS current and RMS voltage, right? So that's why I have written this like this. So voltage is 220, RMS voltage, resistance is given 100 ohm, so it is 2.2 ampere, and voltage will be same, that is 220 volts. Entire voltage will be dropped against this resistor, so it is 2.2 220 volts. Simple answer. Let's move on. An inductor of inductance L and a resistor of R are joined together in series and connected to a source of frequency omega. The power dissipated in the circuit is. So now we know that what is the power dissipated in the circuit. Power dissipated in the circuit is VI cos phi. If you remember average power, power dissipated means the average power dissipated, obviously. Now or this can be written as V square by R or V square by Z, particularly V square by Z cos phi. Okay, now what is cos phi? Cos phi is R by Z. Okay, for RL circuit this is partially not there in the syllabus, but still power, if they ask you to calculate power, you have to use this formula. That's why this is important. So now V is V square, obviously Z is for RL circuit, Z is simply R square, square root of R square plus XL square. XL is omega square L square, so XL square times R divided by Z. Z is again square root of R square plus omega square L square. So we can write this as V square R divided by R square plus omega square L square. So this is the correct option. Correct option is this. Okay, simple. In some cases the phase will be given and you can directly use this formula to calculate the power dissipated. Now, which of the following represents the variation of inductive reactance XL with the frequency of the source nu? Okay, we know that XL is omega L, okay, or omega is 2 pi FL. Now in this case they have given F is equal to nu, and so we can see that XL is directly proportional to nu. So as nu increases, XL will increase, so it will be a straight line relation. So linear equation means this one must be correct, right? Now a 100-watt bulb is connected to an AC source of 220 volts, 50 hertz. Then the current flowing through the bulb is. Now they have given you 100-watt bulb, so power is given 100 watts, okay, and voltage is given 220 volts. Okay, they have asked you what is the current. Okay, what is the current through the bulb? Current through the bulb is 100 divided by 220. Now this particularly, if they don't mention anything, okay, if they don't mention anything, the current means RMS current. If they don't mention anything, voltage means RMS voltage. Okay, if they particularly mention peak voltage, peak current, okay, then it is something else. But otherwise, if they don't mention anything, it should be always RMS current, RMS voltage. Remember that. So 5 by 11 ampere. So 5 by 11 ampere is the current flowing through the bulb. Simple formula, simple equation. P is equal to Vodafone Idea. Just remember that P is equal to Vodafone Idea. Okay, and another thing is vitamin. If you remember vitamin, VIT, remove the T, then it is VI, which is power. Okay, Now let's move on to the next question. The average power dissipated in AC circuit is 2 watt. If the current flowing through a circuit is 2 ampere and impedance is 1 ohm, what is the power factor of the AC circuit? So what is power factor? Power factor is cos phi. Cos phi is the power factor. Cos phi is called power factor. So what is given? P is given, I guess V is given, I is given. So we have to find cos phi. Okay. So the average power dissipated in AC circuit is 2 watt. If a current flowing through is 2 ampere, so what formula we can use? We can use I square R. Okay, this is one formula. Another formula is I square R. Different formulas are there. Okay, you can calculate voltage by multiplying IR, but since we know I square R is another formula, we will use I square R cos phi. Okay, I square is 2 amperes and resistance is 1 ohm, cos phi. So cos phi is equals to 2 divided by 4. So half means 0.5. So 0.5 is the answer. Power factor is a unitless quantity because cos theta, cos phi, any cos function cannot have any unit. It's a unitless quantity. So it has to be unitless quantity. Now question number 18. In Karnataka, the normal domestic power supply AC is 220 volts 50 hertz. Here 220 volt and 50 hertz refer to. 220 volt is the RMS value and 50 hertz is the frequency. So RMS value and frequency. So I discussed this during our regular class, why this is so, and where across the world what type of values, what type of voltages are used. In India, all over India, 220 volt 50 hertz is used. Now a step up transformer operates on 230 volt line and a load current of 2 ampere. The ratio of primary and secondary windings is 1:25. Then the current in the primary. So in the previous problem, that incomplete problem what we have tried to solve, there they have not given the current. Here they have given voltage as well as the current. So this voltage is primary voltage. The load current means this is the secondary output current, right? So here they have given VP primary is 230 volts. Okay, so operates means input voltage, right? And load current means output current. Load current means output current, that is IS, that is 2 ampere. Also they have given the ratio of primary is to secondary is 1/25. Okay, so because secondary has more number of turns, it is called step up transformer. If primary has more number of turns, this is called step down transformer. Okay, now what else we know, that this should be equals to VP by VS, right? So from this we can find VS cross multiply VS. So here VS equals to 25 VP, that is 25 times 230 volts. Now I am not so interested in multiplying yet, because we have to calculate input voltage. Now we know that input power, that is VPIP, should be equals to output voltage VS IS, right? Now VP is 230, IP we are trying to find, VS is this 25 times 230, and IS is 2. Okay, so IS is 2. Now 230 cancels, so IP is 50. Okay, so IP is 50. Now there is a shortcut method for this problem. What could be the shortcut method? The shortcut method to solve this problem is IP by IS is equals to NS by NP, opposite that of a voltage. So you can directly use this method and calculate the current, okay, but at least one current has to be provided so that you can solve this problem. If they directly ask you what is the current, only voltage is provided, then you cannot solve this. You can find the ratio, but you cannot get the exact value. So NS by NP is 25, okay, and IP should be equals to 25 IS. So IS is 25 times 2, 50. This is the shortcut method, okay, to solve this problem. So correct answer is option B. Now let's move on. Question number 20. The output step down transformer is measured to be 48 volt when connected to a 12 watt bulb. The value of the peak current is. So what is this they have measured? They have measured the output voltage is 48 volts. Now output voltage, nothing is mentioned about this voltage. So that means this voltage has to be the RMS voltage. Okay, and power is 12 watt. So power is basically VI. Okay, everything is in RMS. So power is 12, V is 48, I is 1 by 4 amperes, right? So this is the current. Now this is nothing but peak current divided by root 2. This is RMS current, right? So this should be, peak current should be I root 2, that is 1 by 4 times root 2. So how we can solve this? Let me write this in a different way. 2 times 2 root 2 times root 2, okay, times root 2. So what I have done, I have taken this 4, I have divided into parts. 4 is equals to 2 2s are 4. So now I have taken another 2 and I have written this like this. So 1 of the root 2 will cancel, so it will become 1 by 2 root 2. If you are very good with this kind of calculations, then well, you don't need to do this like this. For some weaker students, I have solved this problem like this. Okay, I hope this will help. Now next, 21. The RMS value of current in a 50 Hz AC circuit is 6 ampere. The average value of AC current over a cycle is. So average value of AC in any circuit is always 0. Average value of current, average value of voltage, okay, as long as it is direct sin theta, direct cos theta, average value will be 0. Remember that. Now question number 22. A capacitor of capacitance 10 microfarad is connected to an AC source and an AC ammeter. If the source voltage varies as V is equal to 50 root 2 sin 100t, the reading of the ammeter is. Now we know that capacitor of a capacitance is this, okay, connected to an AC source, and so it is just a capacitor and AC source. So nothing else is connected. I have solved this question, this type of concepts. So here it will behave as a resistor, and that resistance will be XC. XC is nothing but 1 by omega C. Now if you see this equation, what is omega? If you see this equation, this is omega, right? Omega t, 1 sin omega t. So instead of omega, 100 is given. So you can simply write omega is nothing but 100, and capacitance is given as 10 microfarad. 10 times 10 to the power of minus 6, micro means 10 to the power of minus 6. So it will become 1 by 10 to the power of 3 minus 6. So it will be 1 by 10 to the power of minus 3. So it will be 10 to the power of 3. Okay, so this is the resistance. Now what is the current? First they have asked you, first we have to find the maximum current, IM. IM is VM divided by XC. So VM is this, right? 50 root 2. 50 root 2 divided by 10 to the power of 3. So that is, we can write this as 50 root 2 into 10 to the power of minus 3 ammeters, or 50 root 2 milliammeters. This is the peak current, right? Now if this is the peak current, IRMS will be peak current divided by root 2. So 50 root 2 divided by root 2 milliampere, or it will be 50 milliampere. Okay, so 50 milliampere is the correct answer. So if you see all the options are given, they have actually does not make sense except these two values, right? Now let's move on. In a series LCR circuit, the potential drop across L, C and R respectively are 40 volts, 120 volts and 60 volts. The source voltage is. So we know that source voltage VR square plus VL square minus VL minus VC whole square. Okay, so what is VR? VR is given as 60 volts. Almost similar problem that we have solved. Okay, and this is 120, this is 40 whole square. So we will take 10 common, 6 square plus 8 square. I have already solved one, so it will become 10, so 100 volts. So 100 volt is the actual source voltage, right? We have solved this problem before, so that's why I have used some shortcut tricks. And if you are watching from here only, then mention that in the comment below. You can go back and check the previous solution. Okay, I think it is problem number 4 or 5. There we have solved similar question. Now, in a series LCR circuit, an alternating EMF V and current I are given by V is equal to V naught sin omega t and I equals to I naught sin omega t plus pi by 3. The average power dissipated in the circuit over the cycle of AC. So average power dissipated is P equals to Vm Im by 2. Why I am writing that? Because it is you can write this original value also, because we are already familiar with the values. So Vrms, Irms, cos phi, right? So Vrms is Vm by root 2, Irms is Im by root 2 cos phi. Okay, so Vm is Vm Im by 2 cos phi. So based on the information given, you have to you need to be flexible. Okay, you need to be flexible. There is no hard and fast rule that always you have to use this formula. This is your backup formula. If you forget everything, you can start from here. But if your mind is flexible, you know that Vrms is 1 by root 2, Irms is 1 by root 2. So basically if I multiply them, it will be nothing but Vm by 2. So you can directly use that value. Im is given V naught, Im is given I naught by 2, and phi is pi by 3. Phi is pi by 3. So cos pi by 3. So pi by 3 means what? 60 degrees. Cos 60 degree means cos 60 is close to 90. Close to 90 means it will be half. Okay, sin 30 cos 60 means sin 30 is half. Whichever way you want to remember, you can remember like that. I remember like cos 90 is 0, and before 0 it's half, and sin 0 is 0, after 0 it is half. Whatever way you want to remember, you can remember like that. So because it is closer to 0, the smallest value in all the values is half. So that's how I remember. So it is V naught I naught by 4. So correct answer is option B, not 0 in this case. If it was only sin omega t, then the average value would have been 0, because there is a phase difference involved here. You cannot write it is 0. If the phase difference was 0, then also it is not 0. If the phase difference was pi by 2, so one is sin, another one is cos, in that case this would have been 0, because in that case phase difference would have been pi by 2. So if the phase difference is pi by 2, only in that case average power will be 0, right? Now question number 25. A transformer is used to light 100 watt 110 volt lamp from 220 volt mains. Okay, if the main current is 0.5 ampere, the efficiency of the transformer is. So very interesting question. So here whenever we are calculating the efficiencies, we have to start with the power. Always remember, power is the what determines how efficient something is. So what is the power output? Power output is 100 watt. Okay, what is the power input? Power input is V primary, current primary, V primary is 220 volt, current primary is 0.5 ampere, that is 110 watts. So 110 watts is the input power, output power is 100 watts, right? So what is the efficiency? To calculate the efficiency, it should be output by input, right, times 100%, right? So output is 100, input is 110 times 100, so it will be around 90.9 percent. Okay, so it will be 90%. So from the given option, it will be 90%, right? Now let's move on to question number 26. In an LCR circuit at resonance, okay, this is just a theory question. The impedance is maximum? No, impedance is minimum. In fact, the current leads the voltage by pi by 2? No, current and voltage are in the same phase. The current and voltage are in phase? Yes, correct. I just said that. The current is minimum? No, current is maximum. So correct option is option C. Simple question. The average power dissipated in pure inductor, 0. Average power dissipated in pure inductor, average power dissipated in pure capacitor are always 0. Main culprit is resistor who consumes power, right? Now question number 28, I guess this is the last question. A multimeter reads a voltage of certain AC sources as 100 volt. What is the peak value of the AC volts? Now multimeter, whatever device you use, voltmeter, multimeter, ammeter, they always measure IRMS. Okay, so IRMS or capital I is 110 volt. This is nothing but maximum peak value divided by root 2. So the peak value of the current is 100 times root 2. Now root 2 is 1.41, that is 141. Sorry, it is not, I have used wrong symbol, sorry for that. This will be Vm. Okay, so it will be 141 volt. So 141.4 volts. Okay, so this is the correct answer. So I hope you enjoyed this session, and if you think this might help your friend, don't forget to share it with your friends, and don't forget to subscribe to our channel if you have not done so. Thank you for watching.